Okay, so we're back for what I think should be the last video for chapter 9. Thank you for sticking it out this long. Okay, so we are factoring harder trinomials. So remember the easier ones were in this form, but a was equal to 1. And now we have ones where a is not equal to 1. So we might have a 3x squared or a 6x squared, and not one that will pull out as a GCF. So this is on page 6 of your notes, and I just rewrote it here to kind of follow along as we're doing a problem, and I just rewrote it before the video to save a little time. But again, it's right on page 6 of the notes. So we are going to use what we call the AC method for factoring. And before we get to that, let's do that little review problem that's at the top. So thinking again about how multiplying is kind of the opposite of factoring, let's review what happens when we multiply these two binomials. So just like we've been reviewing all day, 3x times x is 3x squared. 3x times negative 4 is minus 12x. 1 times x is 1x. And 1 times negative 4 is negative 4. So now I can combine my like terms, and I would get 3x squared minus 11x minus 4. So let's, again, like we did with the easier ones, let's kind of dissect this and see where these numbers came from. Well, 3x squared came from the first times the first being multiplied. Okay, so that seems pretty reasonable. The negative 4 came from the last times the last being multiplied. Just like before, we see there are different signs that gives us a negative answer. But how about this negative 11? Our two numbers that multiplied to give us negative 4 now do not add up to give us negative 11, right? Why is that? Well, if we go back one step here, when we had just a 1 in front of this, then x multiplied by whatever was here, this became the coefficient. So I would have had negative 4x, and then I would have added negative 4 plus 1. But now this is multiplied by this guy, so that affects what my coefficient is. That affects what I get when I add. So basically this is affected by this first number here, okay? However it splits out here. So we have to kind of have a different method. Now there are a couple different ways we could do this. One is called trial and error. And this may be what you taught or what you were taught in high school, okay? So let's pretend I didn't know this part right now. I'm just given this harder trinomial to factor. I could say, well, I recognize that it's in that pattern of a trinomial. There's no GCF I can pull out. I'm going to factor it. So 3x squared has to be 3x times x, because the only way to make 3 is 3 times 1. I know the signs have to be different, but which one is plus and minus now does matter because of that 3 out front. And I know that 4 could be 1 and 4 or 2 and 2 with one of those plus and one of those minus. So I could try 1 and 4 with a minus here and a plus here, FOIL it out, see if it works. If that doesn't work, I could try 2 and a 2. I could try 1 and 4 in the opposite places. I could try 1 and 4 in the same places but opposite signs. Okay? There's all these different choices I can make. So when I check this, 3x times x would be 3x squared. Okay? You're going to choose things that give you this and this generally. It's this middle term that your choices will determine. So here I would have 3x squared, I'd have minus 6x, I'd have plus 2x, and I'd have minus 4. So you can see I got this and I got this, but my middle terms would add up to negative 4x, not negative 11x. So I know this try is not right, I'd have to try something else. So you can do that, and the more comfortable you are with it, actually, you can kind of see how things are going to combine. It gets a little bit easier. It also is pretty easy when, especially this number and this number are prime, then you only have one option, okay? But imagine if I had something that was like this, 12x squared plus 8x plus 24. Okay, now I don't even know if this is factorable. I'm just making up these numbers. But think about how many choices I have for 12. 12 could be 12x squared could be x and 12x, 2x and 6x, 3x and 4x. And then 24 could be 1 and 24, 2 and 12, 3 and 8, 4 and 6. Think about all those combinations. Okay, so the trial and error gets a little rough sometimes depending on what numbers you're using. So it's nice to also have this method, this AC method, where if we go through these steps, we always get an answer, right? It's never like, oh, we can't figure out we can't find the combination that works. We'll always get an answer here. So we're going to go through the example on page 6. It's up toward the top. So we have 4x squared minus 5x minus 6. So this is called the AC method because we start out by multiplying A times C. Now, what do we mean by A and C? Well, here's my A, here's my B, and here's my C. Okay, so A is 4 in this case. B is negative 5. C is negative 6. So let's multiply A times C. So A times C in this case is 4 times negative 6, which is going to be negative 24. Okay, now remember before we used to look for numbers that multiplied to this and added up to this. So we're going to do the same kind of thing now, but we had to take this number into account somehow. So now we're finding factors of this. So we want two numbers that multiply to AC and add to that B. So when I'm finding these pairs of numbers, it's the same process as before. It's just that instead of just looking at C, I had to multiply A times C to get that. We know that this impacts things, right? So I had to get that impact in there. So if I'm looking at factors of 24, and we've done this a few times now, right? So 2 and 12, 3 and 8, 4 and 6. Different signs, more negatives. So the bigger number in each case is going to be negative. And then we see what they each add up to. 3 and negative 8 are the ones that add up to negative 5. Okay, so I rewrite the trinomial with bx as the sum of two terms using the numbers I just found. So that's what this is. Here's what this means. Here's my trinomial. I'm going to rewrite this, except instead of writing negative 5x, I'm going to write plus 3x minus 8x and then minus 6. Okay, so this and this are the same. I just rewrote this using those two numbers, which means exactly the same thing because 3 minus 8 is negative 5. So it means exactly the same thing. Let me just make this a little neater. This is a 6 here. Okay, now I have 4 terms. They do not all have a GCF because I would have pulled out a GCF at the beginning if they did. Okay, 4 terms, factor by grouping. So remember I said before, if the examples we did, there was a reason why we didn't combine those like terms. It was because we were like at this step where we had already pulled them apart. So now I'm going to factor by grouping. What's in common here is just x. So I have 4x plus 3 left. Here I pull out a negative. It's going to be negative 2. And I have 4x plus 3. Negative divided by negative is a positive. Now at this point, whenever you're factoring by grouping, whether part of the AC method or just on its own, at this point, what you have in those parentheses should match. If it does not match, you did something wrong. Either you pulled out the wrong GCF, like maybe you thought it was a 2 and really 2 didn't go into one of them, or maybe you didn't pull out the big enough GCF, or if they're the same except for the signs, it's probably because of this negative. You probably just forgot that a negative divided by negative is a positive. So just watch that. If they're not the same there, then you can't go on. Go back and check your work again. So now this is what these have in common. And then for each of these, if I pull out the 4x plus 3, I get an x. If I pull out the 4x plus 3 here, I get a minus 2. Last step is to check your work. If we do just kind of in our heads here, 4x times x is 4x squared, minus 8x plus 3x minus 6. We have what we started out with. Okay, so the nice thing about this AC method is you go through these steps, you always end up with an answer. It's not a matter of, can I figure out that answer? Or can I find it? All right, so I'm just going to erase this side because I want to show you one other thing that you can see I mentioned there in the notes. So when we figured out those numbers for B, they were going to be 3 and -8, and I wrote them here. There's nothing saying I couldn't have written them in the other order as long as the signs were correct. So -8 plus 3 also adds up to -5. So what happens in this case? Well, I do the same thing. I factor by grouping. 4x squared minus 8x. Now these have a 4x in common. And what I have left is x minus 2. These two now have a positive 3 in common. And what I have left is x minus 2. When I look at these two terms, what they have in common is x minus 2. And again, if I pull that out of this term, I have a 4x left. If I pull that out of this term, I have a plus 3 left. So at this point, if I look here and here, it looks at first glance like what I have is very different, but it's actually not. Just notice that what was the inside factor here is the outside factor here and vice versa. So you just end up with your factors in the opposite order, which you know is fine because of the commutative property. Okay, so the next example, number 16, is in the notes. And I'd kind of like to leave that one. You can try it on your own, and the answer key for the notes is up. You can always jump on our Zoom class or my office hours to ask questions about it, okay? I'd like to use the last couple minutes here to go on to page 7 and just look at what I have there for factoring strategies. So we learned 5 different methods of grouping, of factoring. Can't talk and write. So we learned factoring out of GCF, easier and harder trinomials, difference of perfect squares, factoring by grouping. Okay. If you look on page 7 here, this part says factoring strategies, also known as how do I know where to begin. So this kind of goes through the steps of you're looking at a problem, what do you even do with it? Well, what you're going to do with it, which of those strategies you use, depends on what kind of problem you have. So you're always going to look for a GCF if possible. Then you're going to look at the remaining polynomial. If there are 2 terms, is it the difference of perfect squares? If so, you can factor it. If not, we don't have anything to do with it. If it's 3 terms, see if it's an either easier or harder trinomial. If it's 4 terms, can you use factoring by grouping? Once you have done that, you need to look at what you have to see if you can go back and repeat that loop again. Okay, so for example, if you do factoring by grouping and you end up with x plus 3 and then x squared minus 16, let's say those are your 2 factors you end up with, well, this one can keep going. You need to do difference of perfect squares, right? That's just an example. But sometimes you factor, what you end up with still can be factored further. So at the bottom of page 7, there are 3 extra additional examples. They say factor completely. Now you always want to factor as far as you can, but if you see the just instructions to factor completely, that's generally kind of a clue that there could be more than one step there. Okay, so even if you factor once, you have to factor it all the way. So I want you to try those. Again, the answer key will be up. You can jump on Zoom Tuesday or Thursday at 10 for our class. You can jump on Zoom for office hours. This week they're Tuesday at 11 and Friday at 10, or whenever works for you, okay? Please feel free to ask me any questions, and make sure you're doing the homework for Chapter 9. All right, thanks, guys.